Welcome to Lecture 6 Embedded C Data Types for 8051 with example using Keil. This one I am able to cover all the data types in the lecture. That's why I have a plan to divide it into two lecture to deliver the embedded C data types. This is part 1. Embedded C data types. The good understanding of embedded C data type is very important. Then only you can able to write the smaller X file. What is the one disadvantage of embedded C is rather than assembly level programming, the embedded C programming, it will take larger X file compared to assembly level programming. Okay, the assembly level programming is more the hardware dependent. Embedded C program is very less hardware dependent. The previous lecture we discussed, I written a embedded C programming as well as assembly level programming for the same logic. The embedded C programming gives the larger X files compared to the assembly level programming. So you must know about these data types, can able to write the smaller X files. These are the data types we are going to be see in this lecture, but I am unable to cover all these 7. I can able to cover only these 2 in this lecture. The rest, the 5 data types, I will cover in the next lecture. This first 4 data type is common for all the microcontrollers. The rest 3 is specific to 8051 and this series. The standard data types in 8051 in C. We just look at here. Unsigned int, size in bit it is 8 bit. The data range is 0 to 255. Why I take it size in 8 bits in this lecture? Because we are using 8051, so it is a 8 bit microcontroller. That's why I chosen 8 bit, because whatever the register inside the 8051, it is the 8 bit register. Okay, it can able to process only 8 bits at a time, but this cross compiler Keil can able to work with 16 bit. Some cross compiler can able to support 32 bit also. If it is a 8 bit, what is the data range? It is 0 to 255. If it is a 16 bit, 0 to 65,535. Okay, for better understanding, I choose the 8 bit over here, but in generally the compiler these days they are using 16 bit minimum as well as 32 bit. Okay, unsigned int, it is 8 bit, data range is 0 to 255, and then signed int, it is a 8 bit, it is minus 128 to plus 127, it is a data range. Okay, the data range more than this 128, 129, 130 won't support. Okay, the data range can be minus 128 to plus 128, 127 only can able to use it. This is the unsigned char, same 8 bit, 0 to 255. Signed char, it is 8 bit, this is minus 128. Yes, minus 128 to plus 127. These 3, the more related to this 8051 is a S bit SFR. We can able to see all the data types in this lecture. But in this lecture I can able to cover only these 2. The next lecture can able to cover this 5 with examples. I demonstrate that example using Keil software also. Just look at this. The first program I am using the unsigned int. I take one program. I want to pass the value 0 to 255 to the port 1. The first line you can see the as include reg51.h, it is a header file. That I hope you came across the header file in the first year BTech courses, that is programming on C. Suppose you are using printf scanf, you must include the header file stdio.h. Here I am using a port 1. It is it is a register. It is a part of 8051. So I have to be include this reg51.h. If you are not include, suppose I am using this p1, it shows some error. Okay, ask you to include the header files related to this register. Just come over here. This is a special function register we are using in 8051 SFR. We can shortly call this. You see the what are the special function register? You see P0, P1, P2, P3. These are the four ports. Each port we can act as the register. It is a 8-bit. Okay, 8-bit register. In this program I am using the P1. It is also a register. It is a part of this SFR in 8051 family. That's why whatever the register I am using in my program, I must include header file as reg51.h. That's why I use over here. I come to the next line, void main, in the bracket void. You can keep void or not using void, nothing changed. Why? Because it is a null. And then open curly braces, unsigned int, the z is a variable. The for loop, this is the syntax for loop. It is a small f. I mistakenly typed f. The first is the initialization, semicolon, condition, semicolon, modify. In the curly braces, here I have written the executable statements. The first have to be initialized, that is z is equal to 0. Next, the condition. If the condition is true, it goes enter into the loop. It is going to be execute this one. Again, it back to the modify, that is what is that increment or decrement of operator. After that, again it back to check the condition. Okay, the condition, this loop has to be continue until this condition is true. Suppose the condition is get false, it comes out of the loop. Okay, the first step initialization, second step check the condition, third step execute the instruction which is inside the loop. If it is true, the condition is true. If it is false, the second step itself, after second step on check, it comes out of the loop. Okay, if it is true, it execute this one, again back to the increment, that is z plus plus. After that, the fifth step again going to be check the condition. The same I written over here for z is equal to 0, z less than or equal to 55. It is true, it comes over here. It assign 0 is equal to P1. Again come back to z plus plus. Now z become 1, so 1 less than is equal to 255. The condition is true, and z is equal to 1. That one is assigned with P1. Okay, it has to be continue until z less than or equal to 255. If z becomes 256, it comes out of the loop. I will demonstrate using this Keil file, new mission project. Okay, yeah, the last lecture itself in the desktop I created a folder that is C programming. Here I am typing the folder name, that is the project name as test4 dot, sorry, test4. It is a project name. It will ask you to set the target device, that is AT89C51. Just choose this one and just give OK and just give no, and you can go for the programming where I typed over here. Okay, due to shortage of time, I just copy the program from. Yeah, this is a program. Okay, I go to the Keil. I paste over here. This is a signed unsigned integer. Now I am going to be save. Okay, with the same folder with the same name, that is test4.c, because it is a C programming. Okay, once I save it, again go for right click and add existing file, that is test4.c. I add it and close. Now I am going for the targets. You can set 12 megahertz. The output you have to be created X file. It is not required when you are going for upload this the X file into the microcontroller. You can go, or else the no need to do this. You can skip this. Okay. Now I'm going to be compile it. Whether any errors or there is no error, no warning. After that, has to be create the X file, that is the build output. Now that file is targeted into that 8089C51. Again, I have to be rebuild it. Fine. Again, I go for run. Okay. Here, the peripheral I have to be choose port 1 because I am using the port 1. Okay, I have to be transmit this value to the port 1. Here it is a run button to what is it, run all the lines at the time. Rather than going this one, I recommend you to what is it, go this step button. Okay, it is going to be execute line by line. You can able to what is that, know about the procedure, know about the working of each and every line. First I am going, okay, first you check the condition is true. Now come to what is that, p1 is equal to z, not yet executed. If once I click this one, it is execute, z is moved to p1. Yeah, fine, it is 0. The next 1 2 3 4 5 6 so on I entered. Suppose I will run the entire thing, the maximum 0 to 255, what is that, transmitted to the port 1. After that, again increment, it become 256, it comes out of the loop. That is the program. The next program I am using the write a C program to send values of -4 to +4 to port 1, same program. The earlier program I used sign, unsigned. Here I am using sign. Suppose you are not using sign, here simply using the in, it will take signed int only. Okay, if you are using signed int also, it is a it will take the negative values. If suppose simply using the int also, it will take the negative values. Okay, the same include void main, signed in, my name, it is an array. In that array, what is it, in the curly braces, I give the values. Okay, now my num of 0 means this is the first 0th position, my num of 1 means this first position, second, third, 4, 5, 6, 7. Okay, now unsigned int is that is a variable. Now for loop z is equal to 0, z less than or equal to 0, condition is true. So my num is z is equal to 0. So my num of 0. My num of 0, what is the position? What is the value over here? +1. So +1 is transferred to p1. Again z plus plus. Now z becomes 1, less than or equal to 8, condition true. Now come over here, my num of 1. The my num of 1, what is that? What is the value over here? -1. So on, what is that? It will increment and it will pass the value 2, 3, 4, 5, 6, 7, 8. If it is 9, it comes out of the loop. Okay. Now, just you can see this the notepad I already prepared. For example, +1. This is I represented in the binary number. If it is +1, the same. Okay. So what is the x value of this number, binary number? You will get 0, 1. Okay. This 4, it is 0. This 4, the lower bytes, it indicates 1. So 0, 1, H. Suppose minus 1, I want to represent in the 2's complement. By the Keil, the compiler also needs to support the negative values in the 2's complement form only. Okay. So that's why I given over here. If you see, suppose it is a minus 1, you get that value 4 ones, 4 ones. If it is a minus 2, the 4 1, triple 1, 0. If it is 1, triple 0, sorry, triple 0, yeah, double 0, double 0, that value is minus 128. If it is unsigned, sorry, signed int, the value from 0 to 127 and minus 1 to minus 128. Already I told, for signed in, the values from minus 128 to plus 127. So this is a range. Okay. So 4 ones, what it is? Minus 1. How to derive? With the help of the 2 complement. We just look at here. The minus 1 means 1 I as usual represented as the binary format. I take a 1's complement, 1 0 becomes 1, 1 becomes 0. Have to be again 2's complement. I add 1 in the LSB, so you will get, what is that? 4 ones, 4 ones. If 4 ones, 4 1 means it is a FF. So minus 1 means, what is that? FF. Okay. Next, the signed integer range, already I told, minus 128 to plus 127. You see, minus 128 to minus 1, 0 to plus 127. So MSB bit indicates, this bit indicates it is a signed digit. Okay. If it is 0 means it is a positive number. If it is a negative 1 means, if it is a 1, it is a negative number, that is an indication. So minus 1. Okay. This MSB indicates 1. That's why it indicates minus 1. So if it is a minus 1, what is the value you will get? FF. Okay. For example, one more example I will take, the minus 2. It is a binary representation of 2. You take a 1's complement and add 1 over in the LSB. So you will get this value. So what is the hexadecimal value? FE. You see, this is a FE. Okay. What is the value you will get? Minus 2 over here. This is the 2's complement representation, that is minus 2. If it is a minus 3, again you can write the binary equivalent of minus 3. You take a 2's complement, you will get, what is the value you will get? FD, FC. Okay, until 80. Okay, here you see 0 to 7F. After 7F, 80 to FF. Okay, this we have to be careful. It is very important thing for signed representation. Okay, it's an important interview question also. Many of the interviews, they ask the question how to represent the negative number with the help of 2's complement. There are other two methods there to represent the negative number. One is 1's complement form, another one is a sign magnitude. But in this lecture, Keil also support 2's complement. The negative number has to be represented in the 2's complement. Now I go in this program for demonstration. Just over here, unsigned int here. I copy this one. I go for Keil software. I stop this earlier program and come over here and paste over here. You see, void main, void, I include the header file reg51 because I'm using the p1, signed in my num. Okay, it is an array. In the curly braces you can write +1, -1 up to -4. Unsigned int, because I'm using the positive values only. 0 positive values, signed means negative values, 0 and positive numbers. As I told over here, you see, the positive numbers, negative numbers plus 0, that is signed int. If it is unsigned int, only 0 and positive number up to 255. Okay, fine. Now I am going to be run this code. Will rebuild. I'm going for run. Okay. Now I'm going to be demonstrate this one. Okay. First I am going to be execute line by line. First I have to check the condition. Yes. Yeah. First we are transmitting +1. Went over here. Again this come over here. Z plus plus. Now Z becomes 1. So 1 less than or equal to 8. Condition is true. So Z is equal to 1. So my num of 1. My num of 1 means the first position. Okay, this is 0th position, first position. Minus 1. What is the minus 1 value? Minus 1 value is the 2's complement representation is what is that? FF. So FF has to be displayed over here. The next third, again it will going to be increment. It becomes 2. 2 less than or equal to 8. So my num of 2. So my num of 2, that is the second position. It is the plus 2. So I am going to be run 1 0. The next I go for the minus 2. The minus 2 representation is what is that? The hexadecimal value is F3, sorry, Fe. So and I am going to be run this one to get a Fe. The next 3 Fd, the next 4 and Fc. Okay, so this is very important. This is there is a three ways to represent the negative numbers: one's complement, sign magnitude, and two's complement. Here, the Keil compiler and microcontroller will support two's complement. Okay, the negative number has to be represented in the two's complement. Again, you have to be remind this one. It is very important. Minus one means okay. FF, FE, FD, FC until what is that 80. Okay, positive values 00 to 7F and 80 to FF. Okay, you have to be remind, or else you can, if it is a negative number, just take a 2's complement of that number, and the MSB bit is what is that? It indicates the sign bit. Okay, thank you.